Hello everybody, and thank you very much for watching. This is me, Mr. P, and this is the first episode in a hopefully long-lasting series where I will show you how to set up Raspberry Pi server, running Docker, running containers. If you'll go and search for Raspberry Pi servers or how to create the Raspberry Pi server on YouTube or just Google it, you'll find thousands of videos and tutorials about how to get one set up. Mine is going to be slightly different from everyone else, as my main focus in creating the Raspberry Pi server is to be used with Samsung DeX in one way or the other to enhance Samsung DeX experience, and in some cases even help to use Samsung DeX more efficiently. So this is why I decided to create a series to show you from zero to fully working server. I already have the Raspberry Pi server running in my home office, and I decided, and I like to use that so much with Samsung DeX, so I decided to go and buy another Raspberry Pi, buy all the necessary things to get this started and basically shoot this tutorial. So like I said, this is our first episode. If you want to follow along, what I will use in this series as follows: Raspberry Pi 4 8GB version model. You can pick Raspberry Pi 4 with 4 or 2GB version, or even Raspberry Pi 3. Just please note that if you will pick Raspberry Pi 3 or Raspberry Pi 4 with 2 or 4GB of model, the performance will be slower compared to what I will get by using Raspberry Pi 4 8GB model. Next thing, you will need microSD card, at least 8GB. We will move the user data to external hard drive. So microSD card is more like just setting up, used just to set everything up, and later we will basically there will be no need to use microSD card. Well, we still need microSD card to boot the Raspberry Pi, but all the user files and everything will be stored externally. This is for a couple of reasons. The external hard drive I'm going to use is SSD. So the reason one, SSD will last longer than microSD card, so I don't want to lose the data. Second, SSD that I will use is 240GB, so it's much bigger compared to microSD card, which is only 32. As example, my current Raspberry Pi home server, the user data folder is about 23GB in size. So it's very close or approaching 32GB limit of microSD card. So using external drive to store user data is, I would say, is a better option. And the second external hard drive we will use is 1TB external hard drive. And that's where I'm going to store all the data, all the files and everything from other containers that we will create in the upcoming videos. Another thing, this server will require a wired connection. Sadly, it's not going to work over Wi-Fi, so make sure you have a wired connection, and your Raspberry Pi needs to have active cooling. Obviously, you can use passive cooling with heatsink or something like a Flurk case. Please note that there is a chance that your Raspberry Pi will throttle at the highest temperatures because it's just not sufficient cooling will be provided for your Raspberry Pi to stay cool. That's out of the way. Let's start by getting ourselves an OS ready. The OS I chose is called DietPi OS, and the reason why is lightweight, it's very easy to use, and I am not a Linux expert. I don't really like to write a lot of commands in a terminal, and DietPi gives a lot of amazing shortcuts and features inside a terminal that helps to set everything up and monitor and fix if something goes wrong very easily. So if you go to the address dietpi.com, you'll find the link in the description below. If you click on the download section, it's going to auto scroll, and you need to pick up what computer or etc. you're going to use. So obviously we're going to use Raspberry Pi 4. It's only one left. We're going to click on that, and I will download 64-bit version. 64-bit version will work with your Raspberry Pi 3 or Raspberry Pi 4, 2, 4 or 8GB versions. So you download Raspberry Pi DietPi OS 64-bit version, and then head to Google Play Store and search for the app called EtchDroid. This is a free app, no root required, and this app will be used to flash the ISO into microSD card. So get yourself a DietPi OS downloaded, get yourself the EtchDroid downloaded. Once you download the DietPi OS, it will end up being the archive version. It's going to be archive. Let me quickly show it to you. So it's going to be archive, 7-zip archive. You need to extract into a folder, and inside a folder you'll have 3 files, and one of them will be DietPi OS image. So once you get that extracted and EtchDroid installed, you can run EtchDroid, but before that, plug in your microSD card in some sort of microSD card reader into your Samsung DeX setup. I'm just going to plug mine into an X.360 OTG cable, OTG port, and run EtchDroid. Once the app runs, you select the first option. Then navigate to a folder where you extracted DietPi OS and select the DietPi image. Click select, then click this line here and then accept the permission for this app to use mass storage. I'm going to click yes. My Galaxy Tab S6 shouts at me that I disconnected the microSD card. That's fine, because instead of Android OS using microSD card at the moment, it's actually an app took over. So it just gives me a summary. 898 megabytes in size DietPi OS will be flashed into 32 gigabyte external microSD card. I'm going to accept that and say flash image. Now inside the notification section, you should see a message showed up giving you information how well is writing the DietPi OS into microSD card. So let this finished. It's going to take about a minute or so, and just leave it running, and I'll be back when it's done. Once DietPi ISO successfully written into microSD card, the message will show up saying USB storage added. If you click on the triangle bit and say just unmount, and that's it. Now you can disconnect the microSD card from your Samsung DeX setup, insert microSD card into Raspberry Pi, connect the power, connect the Ethernet. Do not connect any external hard drives at this stage. Just get the Ethernet connected, power, and obviously insert the microSD card and turn your Raspberry Pi on. Once you turn Raspberry Pi on and everything is connected, head to your home router dashboard and look what kind of IP address your router assigned to your Raspberry Pi. And while you're there, make sure that the Raspberry Pi IP address will not change, as you don't want your IP address, your Raspberry Pi IP address changing somewhere halfway down the road, and then most of the containers of almost all the services that we will install on this Raspberry Pi server will stop functioning because just the IP address has changed. So while my Raspberry Pi is starting up and already know what kind of IP address my router will assign to Raspberry Pi, I'm going to ping that IP address just to make sure that the Raspberry Pi is up. So we're just going to say ping, and here we go. I started to receive these successful ping messages. That means the Raspberry Pi is alive. I will press Ctrl+C to stop it, Ctrl+L to clear the screen, and type SSH space root at 192, and obviously followed by the Raspberry Pi IP address. Press enter. Accept the fingerprint by typing yes and press enter, and default SSH password at this stage is DietPi. You enter DietPi and press enter, and you'll be presented with the first initial setup process. At this stage, just press enter and just leave this running because DietPi will then load all the necessary packages, patches, and all the files, and just leave this running. The initial setup will ask you a couple of times to interact with the installation process. At this stage, I'm just gonna use the tab on the keyboard, select OK and press enter. Next question is, are you allowing to send anonymous information to DietPi server about all the statistics? At this stage, I'm just gonna say opt out and press enter. Now it's gonna ask me, am I okay? Do I want to change the global password? So using tab, I'm gonna select OK, press enter, and then to the new global password. And next message, do I want to change the default password for root and DietPi? I will select OK and press enter, and enter the new password for root user and for DietPi user. And now it's just the last message saying, do you want to disable serial console? I'm going to select OK and press enter. And the last step, you need to scroll down all the way to install, select install and press enter. And click left or use the tab, press OK or select OK and press enter. And that's it. And right now DietPi initial setup will carry on. And once it's done, I'll be back. Once initial setup process finished, you will see the starting page. It gives information about your Raspberry Pi. In my case, as you can see, it's a Raspberry Pi 4 Model B, 64-bit. Currently CPU temperature is 48 Celsius. My IP address for Raspberry Pi, a couple of information about the DietPi OS, and then a couple of quick commands to run certain things inside the DietPi. Let's try a CPU. So if you type CPU and press enter, currently, as you can see, a maximum frequency is 1.9 gigahertz. And what we're going to do now, we're going to overclock to 1.9. To do that, you need to type DietPi-config and press enter. Go to option 3, press enter, then enter on overclocking, and select the last option, which is 1.9 gigahertz. If you're using a passive cooling, I'm suggesting not to change anything here. Leave it as a state safe. But if you're brave and you want to go all the way, just select the highest number, which is 1.9, and press enter. Now using tab, you select back, press enter. Then again, select back and press enter. Scroll to option 6, security options, press enter. Then option 2, change hostname, press enter. And instead of DietPi, I will name my Raspberry Pi change my Raspberry Pi hostname into DeX. So using tab, I'm going to select OK, press enter. Then using tab, select back, press enter. select exit, press enter, select OK and press enter. And now it's asking me to restart. I'm going to select OK and press enter. So while Raspberry Pi is restarting, I'm going to back into the ping command that I wrote inside the terminal, inside the termux, and press enter. And now I'm just going to wait for my Raspberry Pi to come back online. Once I start getting the successful ping messages, I will press Ctrl C, then Ctrl L to clear the screen, find my SSH command to log in via SSH to Raspberry Pi, press enter. And now instead of using a default password, which was DietPi, I need to enter the new password I created during installation process. Press enter, and here we go. I successfully logged in. If I type CPU and press enter, now I can see 1.9 here instead of 1.5 that it was before. So right now that's it. DietPi is fully working. Now let's get the DietPi user files, user folders moved to external hard drive. Right now you need to connect the smallest external hard drive. In my case, like I said, I'm using 240 gigabytes SSD, and that's what I'm going to do now. I'm going to plug in the external SSD drive into one of the 3.0 USB ports. Once you connect your external hard drive, you need to type DietPi dash and start writing drive, but just start with 3 letters, press tab to autocomplete and press enter. Now it loads the DietPi drive manager, and as you can see, this shows me the external drive. We're not connecting the second external hard drive because they both will show up in this numbers and letters mess, and it's hard to pick up which one is which. So you just plug the first one in, find that one, and then I will select this external hard drive, press enter, go all the way down to format, press enter, all the way up to format mode, press enter, and instead of formatting the partition, I'm just going to say format entire drive, then select format, press enter, and select OK and press enter. And now I will wait for DietPi to format. Formatting SSD, and especially 240 gigabytes, will take no time, it's just a couple of seconds or so. Here we go, it did it. Instead of mounting into this folder, which is like, again, numbers and letters that I will never remember, I will delete everything up to /mount or mnt/ and write SSD. And I will know that inside SSD folder, that's where my external drive located. I will use tab on the keyboard to select OK and press enter, and it gives me information saying format is completed, all good, press enter. And now I will go up and select user data and press enter. It's going to tell me that your user files will be moved from mount at DietPi User into mount SSD DietPi User. And I'm doing that because the folder mount is located on the micro SD card. And if somewhere down the road I'm gonna start having a lot of things running on my Raspberry Pi server, so 32 gigabyte version SD card will be not sufficient. It's just gonna basically get full, and the SSD hard drive will last longer compared to micro SD card. That's why I'm mounting inside SSD, and the DietPi will make all the symbiotic links between them that is still gonna be located at this place, but physical files will be located at this place. Anyway, we will select OK and press enter. And now I'll wait for, here we go, so I actually already did. That's actually yeah, because it's just a fresh install, so that's why it took literally a second or so. CD into mount, press enter, ls. As you can see, I have a file here, says SSD, and I have here a file that says DietPi user data. So first, if we're gonna go into DietPi user data, and we will list the content. We're gonna create a file, which we're gonna name it test in capital letters. And we list this. As you can see, the file is created, but if I'll go back into a mount folder, and now we'll go into SSD folder, and I will list that, I'm gonna get the same thing. It says DietPi user data, cd into DietPi user data, and I will list the content. As you can see, test files showed up here again because it's just a link between these two locations, but all the physical files are actually stored on external SSD. I'm going to remove the file by using command rm space and the name of the file. So next, let's connect the actual big external hard drive. In my case, it's going to be 1 terabyte Toshiba SSD. Oh, not SSD, HDD, hard disk drive. The external hard drive that I just plugged in, I used one of the 2.0 USB ports, and the reason for that if I'm going to use the second USB 3.0 port, my Raspberry Pi power supply or my Raspberry Pi will not be powerful enough to spin both devices, both external hard drive, or use both external hard drives. So I rather use the USB 3.0 port for external hard drive where the data is located, just for high data throughput, and USB 2.0 I'll use for external hard drive and then just to store the files, etc. So let's get the other external hard drive sorted. So we're going to type DietPi -drive, use tab to autocomplete and press enter. Wait for this to go through. It's right now scanning the second external hard drive. And let's give the refresh to wait for this to show up. Here we go. I had to give another second or so. If you can see a second external hard drive, you just use option refresh and it's just going to try to detect the external hard drive, the second one. So this is the second external hard drive, and as I said previously, this is like long numbers and letters. So if you connected both of them, it will not show a capacity. It's just going to tell you that there's some sort of SDA1 or SDB1, etc. So you plug in one, sort the DietPi user data files, and plug the second one. So I'm going to select this, press enter, go all the way down to format, press enter, all the way up to format mode. Instead of partition, again, I'm going to use drive, and I'm going to say format, and I will select OK and press enter. This will take slightly longer because I'm formatting the spinning disks, and it's 1 terabyte. So I'll be back when this is done. Formatting successful. It took about 40 seconds or so. Yeah, so instead of mounting inside this numbers and letters, I will mount inside the mount folder. And first thing you probably will say, oh, let's say this is HDD, I'm mounting here. And no, we're going to do in a different way. We're going to mount inside DietPi _user data / and then we're going to call it external. And the reason why I'm doing that right in the next couple of minutes or so, we'll set up the Samba server, and the Samba server will give access to a folder which is DietPi user data. So mounting external hard drive before DietPi user data won't be accessible via Samba. So we need to mount external hard drive inside DietPi user data for us to be able to access from Samsung DeX. So just double check, it's mnt / DietPi _user data / external. And now I'm going to say this is Toshiba. And the reason why I'm doing that external folder will be used in the future to mount other external drives, let's say other NAS services, etc. So we'll know that all the external storage devices will be stored inside the external folder. So I'm happy with that. And actually, instead of Toshiba, I'm going to name it 1TB, stands for 1 terabyte. So it's external, press enter, wait for this to finish mounting the hard drive. It says that's it mounted, and inside the DietPi user data external 1 terabyte. I'm going to select back, exit, and OK. So right now, if I'm going to go inside the mount, SSD, DietPi user data, press enter. I have a folder which says external. I'm going to CD into external, press enter, and I will list the content. As you can see, it says 1 terabyte. I'm going to CD into 1 terabyte, press enter. And if you see lost plus found folder, it means that you're accessing the external hard drive. This folder is automatically created in Linux OS every time you're formatting your external storage device. So that's working. Now let's get the Samba server going. To do that, you need to type DietPi -software. You can press tab to autocomplete, press enter. Go up to the option file server, press enter. Go down to Samba server, press enter. Then OK, enter on OK. Go down to install, press enter, and accept this and press enter. And now I'll leave DietPi to get these things done and install Samba server. Samba server successfully installed. Just to check if it's definitely working, you can type DietPi-services, press enter, and one of them will say SMBD. This means Samba, and it's all working fine. We're going to select exit. We're going to click OK, and that's it. And Samba right now activated, so we can mount the Samba share for inside our Samsung DeX. You can open Samsung files if you want to use that for accessing network storage. You select the network storage on the left, click add network storage, and click network drive. Wait for this to scan and look for the name that you gave to your Raspberry Pi. In my case, that was named DeX. So if I'm going to scroll down, and this is the DeX, I'm going to select that. And now username will be DietPi, and a password is the password you set up during the initial setup process. Once you enter the password and username, you click OK, and here we go. I can access DietPi storage. If I click DietPi, this is the first, third, fourth, and fifth files are located inside the SSD. An external folder that's the folder where we mounted the 1 terabyte external hard drive. So if I'm going to go inside there, I'll find the folder lost plus found. Let's create a folder in here. We're going to right click and say create a folder, and I'll give a name to this folder subscribe, which by the way, that's what you need to do if you like this content and you want to know more about Samsung DeX. So I'll give a name to this folder subscribe. I'm going to click OK. And it's giving me an error message saying that there is no permission, because right now what we need to do, we need to give a permission to DietPi user to access, read and write inside the external folder. To do that, you can type cd/mount/ssd or whatever name you gave, and then DietPi user data. We clear the screen by pressing Ctrl L. If I list the content, this is a folder. We need to give access to to the DietPi. To double check this folder permissions or this folder ownership, you type stat space external. Press enter. As you can see, it says belongs to root and root. To give access to this folder for DietPi user, I can type CHOWN dash capital R. It means recursive. It means this folder and everything else inside the folder and subfolders. Name of the user, DietPi, and name of the file folder, external. Press enter. If I'll select the stat external again, I'm going to say right now this folder belongs and gives a read-write permissions to user DietPi. If I'll select back Samsung my files, I'm already logged into here. I'm going to deselect the external hard drive, create a folder, type the name of the folder, press enter, and I have two folders now, lost but found and subscribe. If I'll go back into a Termux, and if I'll type cd external 1 terabyte, and I will list the content, I have the two folders here, lost plus found and subscribe. These Samsung My Files gives a great access and quick access to your external storage devices, but in my case I like to use Total Commander, and that's what I'm going to show you now how to set this up. If I'll run Total Commander, you need to run LAN Windows Share. If you can see this is a plugin. You can get this plugin by clicking on the plus sign, add plugins, select OK, and then you select this option which says LAN Windows Network. You click install, find this app inside Google Play Store, install it, close Total Commander, complete a close Total Commander, then open again, and once you open again, this option will show up in your list. If you click on here, then I already have, this is the Galaxy, this is my other Raspberry Pi server that I was talking about. If I go into new server, press enter, give a name, I'm going to call it DeX-Pi, click OK. And now under server name, you need to enter the IP address of the Raspberry Pi. And that's what I meant by having the static IP address, because if the IP address of your Raspberry Pi server will change in about 2-3 weeks or so, a lot of connections will break. Username will be DietPi, and the password will be the same password we used for Samsung My Files, and it is the same password you created during its setup in the initial setup process. So I'll enter the password now. I will untick protect with MasterPass. I'm finding this a bit buggy, and to be honest, there's no need for me to have that, but I will make sure that SMB2 is selected. I'm going to click OK. And if I select the DeX-Pi, press enter. And here we go. I'm accessing the Samba inside the Raspberry Pi server. So I'm going to go inside external, 1 TB. As you can see, I have these two folders here that I created before. If I go onto the other side, I will press F6 to move, say copy. Here you go. I have two files and two folders. I'll go back into a Termux, list the content. I have two files and two folders, and the same thing if I'm going to go back into my Samsung My Files, I have two files and two folders. So here we go. This is the first episode of DietPi OS server that we're setting up to be used with Samsung DeX. This was the first episode where we just set up a DietPi OS. We've done overclocking, changed the hostname, mounted a hard drive, moved the DietPi user data into external hard drive, just in case if microSD card goes down. In the next video, I'll show you how to set up backups and how to set up increment backups to make sure that your data is backed up, just in case if something happens. And then will be other videos followed by setting up the Docker containers, and we'll start setting up the services that will help us to use Samsung DeX. Thank you very much for watching. I hope you enjoyed this video. If you liked what you saw here, consider subscribing or just click a like or dislike, leave a comment. If you have any questions about Samsung DeX, we have a Samsung DeX subreddit group. Over 16,000 people are currently members of this group, and we are there ready to help you to sort your Samsung DeX problems. Thank you very much for watching, and I'll see you in the next one. Bye-bye.